Hi children, today you are going to learn 10th class 8th chapter, that is similar triangles, in that exercise number 8.1, and that there are overall 10 problems. Let us solve the 10 problems. This is the first question. Given that an RGP I have written already, let us see what is question in the textbook. In triangle PQR, ST is a line such that PS by SQ is equal to PT by TR. So, in triangle PQR, ST is a line such that this line is dividing these two sides in the same ratio like PS by SQ is equal to PT by TR. If a line divides the two sides in the same ratio, then the line is parallel to the third side. This is Converse of Bpt Theorem. You can know it. And also, what they are given, angle PST or TSP, whatever. PST, angle PST, angle S is equal to angle PRQ, angle R. Angle S equal to angle R. So that this triangle PQR is an isosceles triangle. How can we show that this is an isosceles triangle? I'll tell you. So already, just now I have revealed this solution to you. Now, given that in triangle PQR, ST is a line such that ST is a line such that how it is the line, how this line, this ST is intersecting these two sides in the same ratio. How? See this, PS by SQ is equal to PT by TR. In this way it is divided. So by using Converse of Bpt Theorem, by using of Converse of Bpt Theorem, Converse of Bpt Theorem. What we can say that by using of Converse of Bpt Theorem. So if two sides are divided in the same ratio, then the line which we draw, that is parallel to the third side. This is what we know it. So we can say here ST is parallel to QR. These two will be parallel. QR. ఈ రెండు సైడ్స్ సేమ్ రేషియోలో డివైడ్ అయ్యాక ఈ లైన్ అనేది థర్డ్ సైడ్ కు ప్యారలల్ గా ఉంటుంది. సో if these two lines are parallel, if ST is parallel to QR, then here SQ is a transversal. SQ is a transversal. If these two lines are parallel and here SQ is intersecting these two parallel lines, there SQ is known as a transversal. Then these two angles are known as corresponding angles. So we can write now here angle PST. This angle is equal to angle PQR. Angle PQR. This is equation number 1. And also one of the equation is given here already. Angle given that already, angle PST or TSP, both are same only, that equal to angle PQR, PRQ. This is equation number 2 we will give it. From equation number 1 and 2, we can write that. What we can write from the equation number 1 and 2? See, in the both the equations, the LHS sides are equal. So we can make it RHS are equal. So angle PQR is equal to angle PRQ. So angle PQR, this angle is equal to angle PRQ. These two angles are equal. If the two angles are equal, the sides which are opposite to the equal sides, the sides which are opposite to the equal angles are equal. In any triangle, the sides which are opposite to the equal angles are equal. ఈక్వల్ అంటే ఆ సైడ్స్ ఏవైతే ఈక్వల్ యాంగిల్స్ కు ఆపోజిట్ ఉన్న సైడ్స్ కూడా ఈక్వల్ గా ఉంటాయి. సో we can write here PQ is equal to PR. This is a theorem we have learned in the triangle science properties theorem in the 7th class and 8th and 9th classes also. So we can write now here PQ is equal to PR. If PQ is equal to PR in these two triangles, the two sides are equal. If two sides are equal in a triangle, it is known as an isosceles triangle. Therefore, we can say if PQ is equal to PR, then the triangle PQR is an isosceles triangle. As proved. Simple. We have proved that ST is parallel to QR by using Converse of Bpt Theorem. These two angles are equal by the corresponding angles. Now already this angle is equal to angle R, S equal to R and S equal to Q. By the 1 and 2 we can say that Q is equal to R. If these two angles are equal, the opposite sides are equal. If these two sides are equal, it is known as a isosceles triangle. Hence we have proved this solution. Now we go for the second one. Now we go for the second question here. In the second question, what I have given clearly see in the given figure, in this figure, where LM is parallel to CB, LM is parallel to CB, and LN is parallel to CB. Here LM is parallel to CB, here LN is parallel to CB. So we need to prove that AM by AB is equal to AN by AD. So by using a Bpd theorem, we have to prove that here AM by AB is equal to AN by AD. See that here we go for an easiest method or not one lengthy method is there. One easiest method is that AM by AB in triangle in these two triangles. In triangle ALM and ACB in these two triangles. So AM by AB corresponding sides, that will be equal to AL by AC. And in triangles ALN and ACD, AN by AD equal to AL by AC. Where AN by AC will be equal on the both sides, we can prove that, hence we will get this answer. That's another method that you will learn in the from exercise number 2. That method you can implement in the exercise number 2. Now we use the Bpt theorem. By using Bpt theorem, how can we do it? Now in this first part, you see that in the first part here, where LM is parallel to CB. Now in this triangle ACB, in triangle ACB, here I'll write in triangle ACB, in triangle ACB or ABC, in triangle ABC, in triangle ABC, where this LM is parallel to BC or CB. Okay, LM is parallel to CB. These two lines are parallel, so the line which is intersected these two sides, other two sides, AB side and AC side, are divided into the same ratio by using Bpt theorem. By using Bpt theorem, it's also known as Thales theorem. Remember, so AM by MB is equal to AL by LC. AL by LC. Now here what you need to do it, let us reciprocal this on both sides. Let us reciprocal on both sides. Why we need to reciprocal, I will tell you. So this AM by MB become MB by AM, that equal to AL by LC become LC by AL. Now let us adding 1 on both sides Adding 1 on both sides, we get MB by AM plus 1, that is equal to LC by AL plus 1. So this 1 can be written as 1 by 1 now. Let us take the LCM. AM into 1, that is AM. 1 into MB, that is MB. Plus 1 into AM, that is AM. So do the cross multiplication. 1 into AL, that is AL. 1 into LC, that is LC. Plus AL into 1, that is AL. Now see that here in the numerator part, AM plus AM. Sorry, MB plus AM. MB plus AM. This MB plus this AM is equal to AB. Here we can write AB by it is AM as it is. That equal to here LC plus AL, that equal to total AC. AC by AL. Now already we done the reciprocal now. We do it a reciprocal again. We do the reciprocal again. Why? See that in the denominator we required AB. Here we have AB in the numerator. So this AB should come in the denominator. Already once we have done the reciprocal now we will change it to as it is. As it is position together. Again let us do the reciprocal. Again let us do reciprocal. Then we get here AM by AB is equal to AL by AC. Now this is an equation number 1. You keep it. What we have done in the upside part in triangle ABC, the same thing we have to do it in triangle ABC. Now in triangle ABC, where LN is parallel to CD. LN is parallel to CD. If these two lines are parallel of this triangle ABC, then the other two sides will be divided into the same ratio by using Bpt theorem. By using Bpt theorem, we can write that AN by ND. AN by ND is equal to AL by LC. AL by LC. Let us do the reciprocal again. Let us do the reciprocal. ఇక్కడ ఏం చేస్తామో అదే చేయండి. Let us do the reciprocal on both sides. So what we get? This AN by ND become ND by AN, that equal to AL by LC become LC by AN. Adding 1 on both sides, 1 on both sides, we get ND by AN plus 1 by 1, adding 1 by 1 or 1. LC by AL plus 1 by 1. Let us do the cross multiplication. AN into 1, that is AN. 1 into ND is ND plus AN into 1, that is AN. That equal to here AN into 1 is AN. 1 into LC is LC plus AN into 1 is AN. Let us see that. Now what we got in the numerator? ND plus AN equal to AD. This is will be equal to AD. AD by AN is equal to LC plus AL. LC plus AL equal to AC by AL. Again let us do the reciprocal. Again let us do the reciprocal. Reciprocal అంటే ఏంటి? న్యూమరేటర్ ని డినామినేటర్, డినామినేటర్ న్యూమరేటర్ గా చేంజ్ చేయాలి. సో AD by AN become AN by AD, that equal to here AL by AC. Now this is equation number 2. Now see that equation number 1 and equation number 2. From the equation number 1 and 2, what we can observe? From equation number 1 and 2, we can write that what we can write, see, RHS are equal, AL by AC, AL by AC. Let us make the LHS will be equal. The LHS here AM by AB, which is equal to here AN by AD. So the LHS are also equal. If you make LHS are equal, that is what our argument. AM by AB equal to AN by AD. We got it now? Hence proved. Hence proved. See that very simple. By using Bpd theorem and doing reciprocal and adding 1 on the both the sides, we get first one as a AM by AB by AL by AC. Then here by doing the same thing for the triangle ADC, we get AN by AD equal to AL by AC. So by comparing equation number 1 and 2, we get our required to prove. Now let us go for the question number 3 here. See, the question number 3 is very easy. Here they have given a triangle ABC. In this figure, this DE is parallel to AC. DE is parallel to AC, and this BF is parallel to AE. Here two arrows I have shown. That means these two sides DE is parallel to AC. Here one arrow marks in the sense here DF is parallel to AE. So what we need to prove it? Here DF by FE is equal to BE. BF by FE is equal to BE by EC. This is what we need to prove. Let us go for the proof, children. Very simple. First of all, let us take it. Okay. Here in triangle ABC. In triangle ABC, as he given in triangle complete ABC triangle, this DE is parallel to AC. The first condition is given. DE is parallel to AC. DE is parallel to AC. These two are the parallel. So by using Bpd theorem, what we can write? Tell me. By using basic proportionality theorem, what we can write? You have to write complete theorem here. If a line drawn to the one side of the parallel to the one side of the triangle, it intersects the other two sides in two distinct points, and the other two sides are divided into the same ratio and complete the Ryan theorem. So then only there is a chance of getting a complete marks. Then, so according to the Bpd theorem, what we can write? See that here AD by DB is equal to BE by EC. Complete in the Bpt theorem of this two you forgot now. Now these two sides you forgot. This DE is parallel to AC. So here by using Bpt theorem, AD by DB. Here I write AD by DB is equal to BE by EC. BE by EC. This is equation number 1. Now we write these lines as it is. Now we go for the in triangle ABE. In triangle ABE. Now in ABE triangle you observe which two sides are parallel. In these two triangles, see that in ABE triangle, this DF is parallel to AE. As is given. Here DF is parallel to AE. It is given already in the question. Then by using Bpd theorem, see in this triangle, one line which we have drawn parallel to the one side of the triangle AE. So this DE is intersecting AB at D and BE at F, two distinct points. So these two sides AB and BE will be divided into the same ratio by using Bpd theorem. By using Bpd theorem or not Thales theorem, we can write that AD by DB which is equal to B to F, BF by FE, BF by FE. Now this is equation number 2 and equation number 2. See that now we have completed equation number 1 and 2. From equation number 1 and 2, we can write that, what we can write? See, both LHS sides are equal, AD by DB, AD by DB. So let us make RHS will be equal to satisfy this. So we can write the RHS BF by FE. BF by FE, it is equal to BE by LHS equal అనే కనుక RHS ను కూడా ఈక్వల్స్ గా రాయండి. So we have proved that what we need, BF by FE equal to BE by EC. So hence proved. So I hope you understood. This is very small problem. Now we go for the fourth question, and the solution also have written here clearly to make you understand more clear, because this fourth question and fifth question based on the Bpt theorem and converse of Bpt theorem. So here, see, the fourth question is that prove that a line drawn through the midpoint of one side of the triangle, okay, a line drawn through the midpoint of one side of the triangle is parallel to the third side and bisect the another side and bisect the third side. That is what. See, suppose this is a line in triangle ABC. This is a triangle ABC. This is a line L. Line L is drawn midpoint of one side of the triangle. That means here D is a midpoint on AB. D is a midpoint on AB. So a line L is drawn from the D, where D is a midpoint of the AB, and it is parallel to the third side, this line L, which is parallel to the BC, and we have to show that it is bisect AC. AC ni bisect chestadu చూపించాలి. ఈ లైన్ అనేది D AB యొక్క మిడ్ పాయింట్ నుంచి డ్రా చేస్తే ఇక్కడ AC యొక్క మిడ్ పాయింట్ దగ్గర ఇంటర్సెక్ట్ అవుతుంది అని. దట్ మీన్స్ E is a midpoint of AC అని చూపించాలి. E is a midpoint on AC అని చూపించాలి. So if E is a midpoint of AC, nothing but E is bisected this AC. E అనేది AC ని bisect చేసిందని అర్థం. E అనేది midpoint అయితే AE equal to EC. That means it is bisected. That is what we need to prove. See that in triangle ABC, in this triangle ABC, D is a midpoint of AB. Yes, D is a midpoint of AB. Then a line through the D, a line L through the D, it is parallel to the BC. It is parallel to BC and meeting AC at E. Meeting AC at E. AC ni E దగ్గర మీట్ అవుతుంది అన్న. So RTP, what we need to prove that here E is a midpoint of AC అని చూపించాలి. Or not, here E bisect AC అని చూపించాలి. E అనేది midpoint అని చూపించాలి. So E is a midpoint of AC. So E అనేది midpoint of AC అయితే it is bisect the third side. Third side ని bisect చేసినట్టు. So already here midpoint నుంచి ఒక లైన్ డ్రా చేసినాం. అది parallel to the other side and it is bisect the third side. ఈ సైడ్ నుంచి ఆల్రెడీ ఇచ్చేసాడు. It is midpoint and it is parallel and it is bisect the third side. Bisecting the same, E is a midpoint of AC. That is what we need to prove. Here there are two cases. Either we are drawing a line, no, we are drawing a line. Either it may be intersect exactly at E midpoint, or not, it may not be intersected. ఈ లైన్ అనేది ఇలా డ్రా చేయొచ్చు, కొందరు ఇలా డ్రా చేయొచ్చు, లేదా ఇలా డ్రా చేసుకోవచ్చు, ఎలాగైనా డ్రా చేసుకోవచ్చు. సో there are two cases. The case one, if E is a midpoint, E అనేది మిడ్ పాయింట్ స్ట్రైట్ గా డ్రా చేసాం. E నుంచి L ఒక స్ట్రైట్ లైన్ డ్రా చేసాం which is parallel to the BC. సో సపోజ్ if E is a midpoint అనుకుందాం. ఒకవేళ E అనేది మిడ్ పాయింట్ ఆఫ్ AC అనుకుందాం. If E is a midpoint of AC, then the given statement is become true. E అనేది మిడ్ పాయింట్ అయితే అయిపోయినట్టు కదా. E is a midpoint of AC. If E is a midpoint of AC, then the given statement is proved. ఇంకా ప్రూవ్ చేయాల్సిన అవసరమే లేదు, స్టేట్మెంట్ ఆల్రెడీ ప్రూవ్ అయిపోయినట్టు. ఒకవేళ E అనేది మిడ్ పాయింట్ కాకపోతే, if E is not a midpoint of AC, if E is not a midpoint of AC, there will be E dash అని తీసుకుందాం. ఇక్కడ E అని కాకుండా E dash అని తీసుకుందాం. E may be here or here. You may draw like this or like this now. If E is a midpoint, answer is proved. But E is not a midpoint, you may draw like this or like this. See. Then E dash is a midpoint of AC. Then E dash is a, suppose will be E dash is a midpoint of AC. Then by using Bpd theorem, then E dash is a midpoint of AC. E dash అనుకుందాం, ఇక్కడ E అని కాకుండా ఇక్కడ E dash. Then E dash is a midpoint of AC. By using Bpd theorem, we can write that here AD by dB equal to AE dash by E dash E. Either AE dash by or not AE dash by E dash C అని రాసుకోవచ్చు. So AD by dB equal to AE dash by E dash C అని రాయొచ్చు. But D is a midpoint. If D is a midpoint, then AD is equal to DB. If D is a midpoint of AB, then AD equal to DB. ఇక్కడ DB దగ్గర AB అని రాసుకోవచ్చు AD. Then there is a DB. Instead of DB I can write AD because both having equal length. So AD by AD I can write. I can cancel this AD and AD. I get 1 by 1. So AE dash by E dash C equal to AE dash by E dash C. This E dash C you transfer this side. What do you get? E dash C equal to AE dash. E dash C equal to AE dash. ఈ AE dash అనేది E dash C కు ఈక్వల్ అయింది. అంటే AE dash ఈ లెంత్ అనేది E dash C కు ఈక్వల్ అయింది. ఎప్పుడు ఈక్వల్ అవుతుంది అప్పుడు? When AE dash is length, the length of AE dash is equal to the length of E dash C. When it happens, it only happens when E dash is coincident with E. E dash అనేది ఎప్పుడు? Where AE dash is equal to E dash C, it only happens when E dash in the place of E. When E dash in the place of E, అంటే E dash అనేది ఎగ్జాక్ట్ గా E దగ్గర ఉన్నప్పుడే ఈ AE dash is equal to E dash C అవుతుంది. అంటే E dash అనేది ఇక్కడో ఉండకూడదు. E dash should be coincident with E. So E dash equal to AE dash. It's happened only when E dash is must be coincident with E. అనేది E dash అనేది ఎక్కడ ఉండకూడదు, E దగ్గర ఉన్నప్పుడు మాత్రమే పాసిబుల్ అవుతుంది. So here E dash is a midpoint of AC. అంటే E dash అనేది ఇక్కడ ఏం ఉండకుండా ఎక్కడ ఉంటది? The E dash also will be here only, or the E also will be here only. E dash and E, they are not two different things. E dash and E both will be at only one place. Both also will be one place. But to solve the problem, we have assumed when E is a midpoint, it is proved. When E is not a midpoint, see where AE dash by E dash C కావాలి. When AE dash by E dash C happens, only E dash is the midpoint of E. So when E dash is the midpoint of AC, అప్పుడు E dash ఎక్కడ ఉంటుంది? Midpoint దగ్గర ఉంటుంది. Hence, if any cases, see, in case 1 or case 2, what happens? In case 1 already E is a midpoint. In case 2, E dash also a midpoint. E అనేది midpoint అయింది case 1 లో. So hence proved. E dash, suppose E dash తీసుకున్నాం. E dash కూడా midpoint ఏ. So E dash also midpoint. The distance when it is equal, the distance అనేది ఎప్పుడు ఈక్వల్ అవుతుంది? E dash అనేది midpoint అయినప్పుడే ఈక్వల్ అవుతుంది. So in any case, L is bisects AC. ఈ L అనేది AC ని థర్డ్ సైడ్ ని bisect చేస్తుంది. Hence it is proved. The fifth question also will be the same like this only. Now we go for the question number 5 here. So here we have to prove this question number 5 by using Converse of Bpt Theorem. Prove that a line joining the midpoints of any two sides of a triangle is parallel to the third side. So here, if a line joining the midpoint of any two sides, suppose here triangle ABC, these two sides I have chosen. These two sides, AB side and AC sides I have chosen, and a line I have joined the midpoint of these two sides. Here D is a midpoint on AB, E is a midpoint on AC. These two sides I have taken. Now this line which we have drawn on the midpoint of the two sides of this triangle, this line we have to prove that it is parallel to the BC. అనేది DE అనేది BC కి parallel అని prove చేయాలి. So when we can prove that? By using Converse of Bpt Theorem we can prove. See, first of all, in triangle ABC, here D is a midpoint on AB, here E is a midpoint on AC. That is what I have. Then we have to prove RTP. This DE is parallel to BC and prove cheyaali. This DE we have to show that it is parallel to the BC. Then we can prove that. See that very easy that here prove D is a midpoint on AB. No, D is a midpoint on AB. That means the distance of AD is equal to the distance of DB. Yes or no? The D is a midpoint of AB. So the AD equal to DB. That means AD by DB just say, suppose it is 5 cm and 5 cm. You divide AD by DB equal to 5 by 5 is nothing but a 1 you will get. Yes or no? Like that. AD by DB, AD is equal to DB. These two distances are same. So when you divide, the ratio of these two will get 1. AD by DB equal to 1 by 1 or 1. That is equation number 1. Similarly, here E is a midpoint on AC. So the distance of AE is equal to the distance of EC. That means AE by EC equal to also 1. So AE by EC equal to also 1. From the equation number 1, And from the equation number 2, what we can observe? RHS side both are, the ratios are same. One, then LHS equal to, here AD by DB is equal to AE by EC. AD by DB equal to AE by EC. So this AD by DB equal to AE by EC. Now this line DE is dividing these two sides of the triangle. This line DE is dividing these two sides of the triangle in the same ratio, that is AD by DB equal to AE by EC. So by using Converse of Bpt Theorem, what is Converse of Bpt Theorem? I have written completely here. If a line divides any two sides of a triangle in the same ratio, then it is parallel to the third side. So this line is dividing these two sides of the triangle in the same ratio, that is AD by DB equal to AE by EC. So this line which is dividing these two sides in the same ratio, the line is parallel to the third side. So DE is parallel to the BC. As this we have said by using Converse of Bpt Theorem. So the problem also asked to solve by using Converse of Bpt Theorem. Hence it is proved. So very simple one and easy one. Now we go for the question number 6 solution. Here you can see the question number 6. See that in the given figure, in this figure, where DE is parallel to OQ and DF, this DF is parallel to OR. So that this this EF is also parallel to QR. This EF and QR to parallel and future. So what is given in this triangle PQR, in this PQR triangle, where ED or DE, this DE is parallel to OQ and this DF is parallel to OR. This is what is given. We need to prove that this EF is parallel to QR. When this EF is parallel to QR, remember, when this EF is parallel to QR, now because when this EF is parallel to QR, then these two sides of a triangle PQ and PR divided in the same ratio, like PE by EQ, PF by FR. If it is that, if these two sides are divided into the same ratio, then this line EF will be parallel to the third side by using the Converse of Bpt Theorem. Just now we have proved it in the before problem. Let's go for the proof now. Let us focus on that. We have to prove that here PE by EQ should be equal to PF by FR. How can we prove? Now let us take the triangles here. Triangle POQ. In triangle POQ first. In triangle POQ you take it. In the triangle POQ where this is DE, I already said this DE is parallel to OQ. So by using Bpd theorem, what we can say? By using Bpd theorem or Thales theorem, what we can say that? So if a line parallel to the one side of the triangle, then it intersects the other two sides in the two distinct points, and these two sides will be divided into the same ratio. Hence, we can say that here PE by EQ is equal to PD by DO. PD by DO. It is an equation number 1. So similarly, we are going to be take the other triangle POR. Now in triangle POR, where this DF is given the parallel to OR. Now by using Bpd theorem again, by using Bpd theorem again, we can say that here PF by FR is equal to PD by DO. It is an equation number 2. From 1 and 2, what we can say? From 1 and 2, we can write that. What we can write? See, from the equation number 1 and from the equation number 2, the RHS sides PD by DO, PD by DO are same. So let us make the LHS are equal. Hence we can write this is PE by EQ, which is equal to PF by FR. So see that now it is an equation number 3. So what happens here? The two sides are divided to the same ratio. The line EF, the line EF is dividing sides PQ and PR in the same ratio. So by using Converse of Bpt Theorem, we can say that this EF is parallel to QR. EF is parallel to QR. Hence, proof. అంతే కదా, ఈ రెండు సైడ్స్ అనేవి ఈక్వల్ రేషియోలో డివైడ్ అయ్యాయి అంటే ఆ లైన్ ఏదైతే ఈక్వల్ రేషియోలో డివైడ్ చేస్తుందో ఆ లైన్ అనేది థర్డ్ సైడ్ కు ప్యారలల్ గా ఉంటుంది. అదే మనకు కన్వర్స్ ఆఫ్ బీపీటీ థీరం అనేది తెలియజేస్తుంది. Now we go for the question number 7. Here in the question number 7, once you can look at your textbook that in the adjacent figure A, B, C are the points on OP, OQ, OR respectively such that AB is parallel to PQ and AC is parallel to PR and so that BC is parallel to QR. Let's see that I will explain you that question here. Given that an RTP I have written here in triangle PQR. Here in this triangle PQR, here A is a point on OP, here B is a point on OQ, here C is a point on OR, such that here AB is parallel to PQ, AC is parallel to PR. So we have to show this BC is parallel to QR. When we can show this BC is parallel to QR, ఎప్పుడు చూడగలుగుతాం ఈ BC అనేది QR కు parallel అని? If in this triangle QOR, ఈ QOR అనేది ఒక ట్రయాంగిల్ గా తీసుకొని ఈ ట్రయాంగిల్ లో దిస్ టూ సైడ్స్ OB by BQ, OC by CR అని ప్రూవ్ చేయగలిగితే ఈ టూ సైడ్స్ సేమ్ రేషియోలో డివైడ్ అయ్యాయి అని ప్రూవ్ చేయగలిగితే ఈ BC అనేది QR కు parallel అని ప్రూవ్ చేయొచ్చు by using Converse of Bpt Theorem. So let us go for first. We have to focus on that OB by BQ and OC by CR on that concept. If they are divided into the two equal ratio, else by using our Converse of Bpt Theorem, BC is parallel to QR. So let us take the first triangle POQ. In triangle POQ, where in this POQ triangle, here AB is parallel to PQ. AB is parallel to PQ. So by using Bpt Theorem, what we can write by using Bpt Theorem here? This line is parallel to the one side of the triangle and it divides the other two sides in the same ratio. No? So we can write here PA by AO, which is equal to OB by BQ. OB by BQ. It is equation number 1. Similarly, we have to take this triangle now POR. In triangle POR, so what we can write here? AC is parallel to PR. So what we can say here by using Bpt Theorem again? By using Bpt Theorem, we can say that this AC line is parallel to the PR. So this AC line intersecting PO and OR, and it will divide this PO and OR into the same ratio. So PA by AO, which is equal to OC by CR. This is equation number 2. So from equation number 1 and 2, we can write that. What we can write? See, LHS sides are equal. PA by AO. Here PA by AO in the equation number 1 and 2. So RHS, let us make it equal. OB by BQ, which is equal to OC by CR. So where OB by BQ is equal to OC by CR. In triangle QOR, here BC is dividing OQ and OR in the same ratio. So by using converse of Bpt theorem, we can say here BC is parallel to QR. If BC is parallel to QR, that is what we need to prove it. So hence proved. We have proved this. Very simple. ఒకసారి POQ triangle తీసుకోండి, ఇంకోసారి POR triangle తీసుకోండి. Here PA by AO is equal to OB by BQ. నెక్స్ట్ సారి మీకు POR triangle PA by AO is equal to OC by CR. Equation number 1 and 2 will get it here. OB by BQ is equal to OC by CR. ఈ రెండు sides in QOR triangle OQ and OR sides are divided into the same ratio. Then the third side, the BC, will divide the OQ and OR in the same ratio. So BC is parallel to QR. Now we go for question number 8. The question number 8 I have written on the board. See that here ABCD is a trapezium, is it? So let me construct here trapezium so that you can understand clearly. So here what happened? See this A, B, C, D. This ABCD is a trapezium. So this ABCD is a trapezium. In trapezium, one pair of opposite sides are parallel, already we know. So now when AB is parallel to DC, already given, and its diagonals are intersecting each other at O. The diagonals, opposite sides you join, opposite vertices you join, you will get a diagonals. AC diagonal and BD diagonals intersecting at point O. Show that, see that they given that now. ABCD is a trapezium and where AB is parallel to DC and here AC and BD, the diagonals AC and BD are intersecting each other at O. Intersecting each other at O. Then we need to prove, what we need to prove here? RTP. Required to prove AO by BO. AO by BO, which is equal to CO by DO. CO by DO. This prove cheyali. Okay. Then we go for a little construction here. Little more construction we require. What is the construction? Let us draw a line. Let us draw a line which is EO. Let us draw a line which is EO. Okay. Let us draw a line EO such that such that where this EO should be parallel to DC. EO is parallel to DC and this EO should be parallel to AB also. In such a way, EO is parallel to DC and this EO is also parallel to AB. In such a way, we have to construct EO. And to construct this topic, to prove this. Okay. Now what we have to do it? Very simple. Now we go for the proof. Now you take a triangle. You take one triangle now. ACD triangle. You take only ACD triangle and forget about this. You take a ACD triangle. So in the ACD triangle, what we can observe in ACD triangle? This EO is parallel to DC or not? Already you know this DC. In such a way we have constructed EO. So here this in triangle ACD, this line is parallel to the one side of the triangle, and these two sides will be divided to the same ratio by using Bpd theorem. So by using Bpd theorem, we can write that. What we can write here? See, AE by DE, AE by DE లేదా ED ఎలా విధంగా రాసుకోండి. AE by ED అని రాసుకోండి. AO by CO, AO by CO, ఎందుకంటే మనకు CO కావాలి, OC కాదు. ఓకే, AO డిస్టెన్స్ అయినా సరే, OA డిస్టెన్స్ అయినా సరే సేమ్ గానే ఉంటుంది. OC డిస్టెన్స్ అయినా, CO డిస్టెన్స్ అయినా సేమ్ గానే ఉంటుంది. సో AO by CO, here AE by ED, then AE by DE we have written, and AO by CO we have written. This is equation number 1. Keep it as a equation number 1. Similarly, now see that in triangle, what we have to take? Now actually it was joint lines. Now we have to take a triangle, this triangle, ABD triangle, ABD, where this EO is parallel to AB. EO is parallel to AB. AB మాత్రం ఖచ్చితంగా. Now by using Bpt theorem, now in this ABD triangle, this EO is parallel to the one side of the triangle, and this intersecting into the two sides AD and DB. So it will divide into the two equal ratio. So by using a Bpt theorem, we can write that, see, AE by DE, AE by DE is equal to BO by OD or DO. This is equation number 2. From 1 and 2, from equation number 1 and 2, we can write that, what we can write, see that LHS sides are equal on the both the sides, both the equations. Then RHS will make it equal. The RHS are AO by CO is equal to BO by DO. But what we need to prove it? AO by BO we need to prove. So these two will interchange. Only these two will be interchange it. So these two will be interchanged. Now it is dividing. It will multiply if you transfer. So however this CO will be in the numerator. ఇది డివైడ్ అవుతుంది, ఇకపోతే మల్టిఫై అవుతుంది. మల్టిఫై అయితే మళ్ళీ ఇక్కడ CO వస్తుంది. CO అంటే న్యూమరేటర్ పార్ట్లో ఉన్నట్టు. Now it is, see, it is multiplying here. It will divide if it comes. So let us change this to be get the answer AO by BO. This BO comes here. This CO will go here and DO. Hence we got the answer as proved. Therefore hence proved. So this is what the solution, and this problem is very important for the next exercise also. You need to concentrate this, and same kind of problem is also there in the example problem. Now you can also refer the example number 3 to understand more about this problem. You can refer the example number 3. So I hope you understood this, and the next question is, that is 9th question. The 9th question is a construction. To do the construction we require geometrical instruments, and also in the exercise number 8.2 we have some more construction of similar triangles. So here one exercise, one problem of 9th question, and there we have 3 questions of constructions. So these 4 constructions we will do it at a time in a separate video. Till that time you practice these 8 questions of 8.1 exercise. Then we go for the 8.2 in our next exercise, and also constructions in the separate video. Thank you for watching this. Thank you all children. Bye.